Blocks, let's answer a few questions using this figure. Okay, name two different planes in the figure. Notice we have one plane going this direction, the orange plane. We have a second plane going up and down, the blue plane. Now remember, they can be named in different ways. So we have a blue and an orange plane, but we cannot name them that way. The blue plane, notice, has this cursive N here, so we could name it plane N. And the orange has the cursive F, so we could name it using a cursive F, if I can do that. It's been a while. We can also name both of them using any 3 points on the plane. So let's look at plane N. B is on that plane, goes right through it. D is on that plane. A is on that plane. We wouldn't want to do B, C, D because notice they're in a straight line together, and that would just be a straight line. You have to have something that goes up into the plane. So A, B, D is another name for plane N. Let's do the same for F. Let's name 3 points on the plane. Well, E is on that plane, D is on the plane, and C is on the plane. So we could name it D, E, C. You could also use B with those. Okay. Let's name a point on plane N. Name any point on plane N. It's the blue plane here, so anything that passes through, you can name any of those points. D, C, B, and A. Any of those would work. Right, next, name a point on plane F. So here's F. F is our orange plane, and it takes a while to get used to visualizing these three-dimensional things. Okay, what points are on plane F? B is, C is, D is, and E is. So you could name B, D, C, or E, any of those. Name the intersection of planes F and N. So where do they come together? Where are they crossing one another? Notice N is going upwards this direction, and plane F is going across. Where are they coming together? Where do those meet? Notice they meet right here in the middle at this line. The intersection of 2 planes will always be a line, okay? And in this case, it's line BD or DB. Remember, you can name it in either order. And finally, name the intersection of the line AC and plane F. So let me clear my screen. Okay, so we've cleared our screen. Let's take a look. What would that intersection be? Name the intersection of line AC. So first find the line through A and C. A lot of times it helps to just trace it. If you're on a computer screen, you can just put your finger up there, trace A to C. What line am I getting? That line right there, AC. We want to know, where does it intersect plane F? Well, plane F is this flat orange surface here. Okay, so it's this whole thing. I should have used a different color. Where are they coming together? Notice this is like a flat surface with something stabbing right through the center of it. Where is it stabbing through? What is that intersection? And if you take a look, it's at that point C. So the intersection of a line and a plane many times is a point. The intersection of 2 planes many times is a line. Let's take a look at this question. 4 points, P, Q, R, and S, are coplanar. That means they lie on the same plane. But only 2 at a time are collinear. Suppose a line is drawn through each of the points. How many lines can be drawn? Okay, so let's do a plane. This is where you take out pencil and paper and take a look for yourself. We have a plane. We have P, Q, R, and S. It says no more than 2 of them at a time are lined up. Okay, coplanar means they're all on the same plane together. And notice I've drawn it here so that I cannot draw a straight line through 3 points, only 2 at a time. Okay, All right, let's take a look. How many lines can I draw? Let me get a new ink color. We'll make this. Hey, well, I can draw a line through Q and S. There's one. I can draw a line through P to R. There's two. I can draw a line through P and S. There's three. Through S and R, that's four. R and Q, that's 5, P and Q, that is 6. We can draw 6 lines. Now you'll have a lot of problems like this in geometry where they give you a situation and they ask you to put it together and figure it out. You will need to draw a lot of things out. Geometry is a visual math. It needs to be drawn out, it needs to be labeled. Okay, so a lot of times you'll just have to go through the instructions up here and make a drawing of it. So 4 points we put on there that were coplanar on the same plane. No, only 2 at a time are collinear, so we knew that only 2 could be in a straight line. Okay, so our answer here is 6, but again, a lot of times in geometry you're going to have to draw it out. Finally, in this introduction geometry, we do what are called proofs. We prove that things are true. We come to a conclusion about a figure. In doing that, we use axioms, postulates, theorems, and corollaries. Now, an axiom is a basic assumption that's used to build theorems. Okay, so an axiom, something you really don't have to prove, it's something you just know. Okay? The sun will come up in the morning. That is an axiom. It just happens. You don't have to prove that it happened. Okay? A postulate is a statement accepted as being true without proof. Again, this is very similar to an axiom. It's something that you just know is true. It doesn't require any proof. It doesn't require any properties that we will be memorizing. Theorem is a proven statement. Someone actually had to go through the steps to show you, yes, this is true. It's just like in a science class, when at the beginning of an experiment you have a hypothesis, okay? You test that and show it's true. Theorems are things that are shown to be true using properties. And actually using axioms and postulates, we use those to create theorems. And a corollary. It's a theorem that follows directly from another one. So maybe you've proved something up here, and it directly follows to make a corollary. Okay, so one of those things is maybe when 2 lines intersect to make a 90-degree angle, we call those perpendicular. Okay, so maybe you would say that perpendicular lines intersect to make right angles. A corollary for that might be if 2 lines intersect to make right angles, then they're perpendicular. It seems funny because it's almost like I'm just saying what I said backwards, but that's how a corollary works. It is just following from something else that has already been proven.